So the last example we're doing in this section is asking the same questions as the previous example, but it's going to involve trig functions. So first step, find the critical numbers. That means taking the derivative of the function. So the derivative of the sine is the cosine. So the derivative of the first part is square root of 3 times the cosine of x. The derivative of the cosine is negative the sine of x. We set that equal to 0. And we need to put it in a form where either we can factor out something or we can create a separate trig function that's maybe a ratio of these two. And that's what we do. So what we're going to do is we're going to add the sine of x to both sides. Then we're going to divide both sides by the cosine of x. But the sine over the cosine is the tangent. So we end up with that the first derivative is 0 when the tangent of x is equal to the square root of 3. So we need to find the solutions, the values of x, where this is true. Now this is one of these pi over 6, pi over 4, pi over 3 type solutions. I don't think I mentioned in this class yet, but all students take calculus. That's our little thing to remember where functions are positive. So this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. So what it says is that all of the trig functions, meaning sine, cosine, and tangent, are positive in the first quadrant. The sine is positive in the second quadrant. The tangent is positive in the third quadrant. The cosine is positive in the fourth quadrant. So we can tell from this that the tangent, which is positive here, is positive in the first quadrant and positive in the third quadrant. So our solutions are in Q1 and Q3. So the question is, where does the tangent of x equal the square root of 3? Well, let's just think about this. Let's say this is x. 0, pi over 6, pi over 4, pi over 3, pi over 2. Those are the three things: 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And what I'm going to do is here put the sine of x and the cosine of x and the tangent of x. So the sine and cosines, those are easy. What you do is the sine, you start with 0. You go to the next number, which is 1/2. Then pi over 4 is the square root of 2 over 2. Pi over 3 is the square root of 3 over 2. And pi over 2 is 1. So those are the 5 numbers that are associated with those 5 angles. And you start at 0 and you go to the next larger one. Now the cosine, you just reverse everything. So reverse the order. So the 1 now becomes there. The next term is the square root of 3 over 2. You go up 1, square root of 2 over 2, 1/2, 0. You can see at pi over 4, they're both the same value. Now the tangent is sine divided by cosine. So let's do the easy ones. Sine divided by cosine, you get 0 divided by 1, which is 0. Here we get 1 divided by 0, which is undefined. Pi over 4, it's 1 because they're the same. If you divide 1/2 by the square root of 3 over 2 and you simplify, you get the square root of 3 over 2. Now you get square root of 3 over 3 because the 2's cancel out. What you actually get is 1 over the square root of 3, but when you redo it so that you get the square root in the numerator, you get the square root of 3 over 3. And for pi over 3, you get just the square root of 3 because the 2's cancel out at that point. So those are the tangent things. 0, square root of 3 over 3, 1, square root of 3, undefined. Again, they're in increasing order. This is less than 1, this is 1, this is greater than 1. So, to answer our questions, in Q1, in the first quadrant, x is equal to, well, what we're looking at, square root of 3. Square root of 3 is pi over 3. Now in the third quadrant, x is equal to pi plus pi over 3. This is the reference angle. Pi plus pi over 3 is 4 pi over 3. So my two solutions are when x equals pi over 3, the tangent of pi over 3 is the square root of 3, and the tangent of 4 pi over 3 is the square root of 3. So we use that information to create our table where our domain is not negative infinity to positive infinity, but is from 0 to 2 pi. So we still have the same headings here: the interval, the x value, the sign of the derivative, and our comments about decreasing or increasing. So we go from 0 to pi over 3. We go from pi over 3 to 4 pi over 3. And we go from 4 pi over 3 to 2 pi. So we pick x values that are in these. So you pick the easiest ones, which probably are pi over 4, because that's less than pi over 3. Then I can just pick pi. I could pick pi over 2, or I could pick pi. Pi is probably easier. And here I have 3 pi over 2. So that's between these two values. These are on the axes, so those are easy to evaluate. This one, the sine and the cosine are equal to each other. So if we go back to our expression for the derivative, it's the square root of 3 square root of 3 cosine of x minus sine of x. So that's the derivative. So we're going to evaluate the derivative at these three values of x. So you'll get the square root of 3 times the cosine of pi over 4 minus the sine of pi over 4. Well, these are both the square root of 2. So you get the square root of 3 times the square root of 2 over 2 minus the square root of 2 over 2, which is equal to the square root of 3 minus 1 times the square root of 2 over 2. And the square root of 3 is greater than 1, so this is positive. Therefore, this ends up being positive. I could plug that in my calculator and find out what it is, but I really don't. I'm not worried about the value. So that's positive. If we evaluate the first derivative of pi, we get the square root of 3 times the cosine of pi minus the sine of pi. Cosine of pi is negative 1. Sine of pi is 0. So you can see we get a negative number. That's negative. So it's negative. And then we do the first derivative of 3 pi over 2. So we get the square root of 3 times the cosine of 3 pi over 2 minus the sine of 3 pi over 2. And cosine of 3 pi is 0. So we get negative the sine of 3 pi over 2, which is negative 1. So we get 1, which is positive. That's positive. So what we'll get is increasing, decreasing, increasing. So what that means is we're going to have a local maximum there, and we're going to have a local minimum, increasing, decreasing. So it's max. Here we have minimum. So let's see if we can draw a curve. So I need a page. Where's my page thing there? There we go. Let's draw a graph. So actually, let's evaluate the function at these critical numbers. So I'm going to evaluate that function. So I need a page in here. So what we want to do is we want to evaluate the function at pi over 3, and also evaluate the function at 4 pi over 3. So the original function was square root of 3 sine x plus cosine x. So we get the square root of 3 times the sine pi over 3 minus the cosine pi over 3. You can plug that in your calculator, but let's just try to do it. Actually, let's just plug that in our calculator. Make sure it's in radians, which it's not. At least mine's not. So we get the square root of 3 times the sine of pi divided by 3 minus the cosine of pi divided by 3, and I get 1. And if I do 4 pi over 3 instead, I get -1. So that's my maximums and minimums. So let's make, I'm going to put a line in here at this point, and we'll say that's +1 and that's -1. It's just used to help me guide me to do this thing. And let's go, we'll say this is 1, 2, 3, 4. This is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. So it says at pi over 3, which is going to be about here, that we have +1. And at 4 pi over 3, we have, which is about right here, we have -1. So we're going to have maximum, it's going to go through here, it's going to be a minimum, and ultimately this thing has to come up through here, and it has to come back up here. So if you go, this is pi over 3, so we're going to go right there. It's come back up to the maximum there. So I guess it has to go through some kind of thing like that. So you see you have two x-intercepts, one here and one there. So let's go ahead and let's plot that thing. Square root of 3 times the sine of x plus cosine of x. And we want to go from negative, let's say -2 times pi to +2 times pi, and we go from -2 to +2. And we'll graph that thing, and there's a problem here with the syntax. It's probably this thing. I think we actually have to put like a % sign or something in there, and we probably take away these parentheses. Each program has different syntax. Oh, Still apparently wrong. Help. Pi is just capital Pi. Okay. Pi. Pi. And actually what we did, if we want to be exactly right, we're going to 5 is it 5 pi over 2? Yeah, 5 pi over 2. 5 halves pi. Do the same thing here. 5 over 2 pi graph. Must have done something wrong when I was. You can see I have the maximum minimums in the right place. Let's go back here, figure out what it did. Okay, so instead of putting in the calculator, get the square root of 3. Oh, this is plus. That was the problem. So the sine of 3 pi over 3 is equal to the square root of 3 over 2. The cosine of pi over 3 is equal to 1/2. So here you get square root of 3 times the square root of 3, which is 3 halves plus 1/2, which is equal to 2. And you can do the same thing there. You get negative 2. So I don't have to redraw this whole thing. This is going to be 2. This is going to be negative 2. And now it matches up pretty closely. So this is those are the homework assignments. You can pause it to copy it. I'm going to stop the recording.